Hello, I am Emily Christner, and I'm a second-year biology major.
And I'm Jared Christner, a second-year mechanical engineering major.
Yes, we are twins, just to clear that up. So the problem we are solving today is Chapter 17, Section 2, Problem 8, which is the following cell has a measured potential of 0.27 volts at 25 degrees Celsius. And the following cell is this. And the question is, what is the pH of the solution in the anode compartment? So, what are we looking for? We are looking for the pH, which the following equation is. Which means we're trying to find H plus concentration, which we don't have, but we're going to find it. So, we're going to use the Nernst equation to find this, which is which this is usually written as Q, but we're going to write it out a little bit more. And, okay, so before we can use the Nernst equation, we have to find three things, which is 1, what is the cathode and anode? 2, the balanced reaction. And 3, the E-cell standard, which is the standard conditions E-cell. And so, to start with the first step, so we have to look at the standard cell notation, which is platinum solid, H2 gas, H plus concentration with unknown concentration, you can see where that's going, with nickel 2 plus with 1 molar concentration, and then nickel solid. So, now what? So, the platinum here, this is just an area where, like, the reaction can happen, so we can ignore this.
It is chemically inert.
Yep. That's right, Jared. And so, we know that this is the anode, because the anode comes first in cell notation, standard cell notation. And this is the cathode. So knowing this, we can write our half cells. Move this up. This is a live show, everyone. Mistakes or typos will be made. So we know the anode oxidizes and the cathode reduces. So if we look at our half reactions located in Chapter 17, Section 3, we know that the half cell reaction for hydrogen is this, which has a standard E cell of 0 volts. This is kind of what they base everything, the whole scale off of. This is why it is 0. And then nickel 2 plus is this. So now you may be wondering, because nickel has a negative E cell, why it is the cathode when it is negative. So Jared, can you answer this question?
Well, it's because we are solving for the E cell at non-standard. So if it was just standard, then yes, the nickel would be the anode and the hydrogen would be the cathode. But since it's not standard conditions, the nickel can act as the cathode instead of the anode.
Okay, cool. So now we're going to rewrite our half reactions to reflect the actual reaction that's going to happen. So the cathode is going to be this, which is going to be nickel reducing. And then the anode is going to be this. So since these have the same electrons, we can just combine these equations. We don't have to even out the electrons, because that's what's important in a redox reaction. So our reaction is going to be nickel 2 plus H2 equals, reacts to make 2 H plus ions plus nickel solid. So from this, we can now calculate the total E cell, which would be just
Cathode minus anode.
Yep. So that would, since hydrogen is 0, we can just say the E cell is so this is what we will use in our Nernst equation.
So now we can use the Nernst equation now that we have everything that we need. Having trouble there, Em?
Yep, the computer has crapped out on me. Okay, now we can go.
So let's write the Nernst equation.
So the Nernst equation again is E cell not at standard conditions minus the E cell at equals the E cell at standard condition minus
R T over NF natural log of Q.
What do these stand for, Jared?
So well, Q is the ratio of products, the concentration of products over reactants, and is given by that. Make sure
It's given by this. Which equals to R's, it's H plus.
note that the exponents are the same as the coefficients in the balanced reaction. So H plus will have a exponent of 2, and nickel 2 plus will all have an exponent of 1.
Just moving everything up since everything is refusing to do so. There we go. That's what I wanted. Okay, continuing on.
So now for all the constants that we have to mess with. So first is the R, and that's going to be the gas constant. So in this case, it will be equal to 8.314 joules per Kelvin mole. And then next is T, which is the temperature in degrees Kelvin. Well, in Kelvin. Kelvin doesn't have degrees.
Almost misspelled degrees there, but I saved that.
And then N is the number of electrons exchanged in the balanced reaction. So in our case, N is equal to 2.
Okay.
And then F is the Faraday constant. And that is equal to 96,485 coulombs per volt mole. So, next, we just insert the values. So our E cell is 0.27 volts. That's equal to our E cell standard, so it's negative 0.257 volts, minus 8.314 times 25 plus 273, since we have to convert the Celsius into Kelvin, over 2 Rn, and the Faraday's constant, so 96,485. And that's multiplied by natural log of Q. So that'll be your H plus concentration squared over 1 molar. So next we have to solve for H.
Okay.
So let's move the voltage over to the other side. So it'll be 0.527 volts is equal to, and then I'm just condensing all this, so you can just plug into your calculator, negative 0.012839 times the natural log of concentration of H ion squared over 1 molar. Next, we'll divide both sides by negative 0.012839, giving us negative 41.047, which is equal to the natural log of our hydrogen ion concentration squared over 1 molar. Next, we have to put both sides to the power of e to cancel out that natural log. So it'll be e to the negative 41.047 is equal to the concentration of H plus ions.
I'm just showing how E cancels right now.
Yep. Over 1 molar. So you can multiply that 1 molar over to the other side, which gives you the same value, but it'll give you the right units. Is equal to sine squared. So now we take the square root of both sides to isolate H plus. And we find that the concentration of hydrogen ions is 1.22 times 10 to the negative 9th molar. So lastly, we have to solve for the pH. So if we remember, pH is equal to the negative log of our hydrogen ion concentration. So if we plug in that value, we find that the pH is equal to 8.91.
Thanks for listening.